Yes. So today we are discussing about negative number representations. Okay. So everyone knows about ones and twos complements. I'm also using this signed magnitude representation. So here binary number representation, if it is positive number, there is no problem. It is coming to a negative number, we have to go for this ones and twos complement. Why? Because if you go for a negative numbers, borrowing is involved. So for this borrowing, complexity will be more for designing the circuit. To overcome that, we are going for a signed representations, can be represented in sign magnitude form, ones complement form, and two's complement form. So in signed magnitude representation, see here below in color red text. So it is ambiguous. So zero is represented in two ways in signed magnitude representation. Even in one's complement also, zero is represented in two ways. That let me explain with an example. But before going to that, in two's complement representation, zero is represented in same, it is unambiguous, you're not having two combinations for zeros. So we will start with signed magnitude form. So this is your signed magnitude form. So in this signed magnitude form, one bit we will store for in MSB we will store for sign. As we are in a negative number representation, one bit we will use as for sign bit. So see here, let us consider, everyone knows what are registers, right? Is everyone knows registers? May tell me what will be the size of registers? Size of registers. Anyone? Will it be in terabytes and gigabytes like that?
No, ma'am, it will be in megabytes.
No, ma'am.
It will be in bytes, right? So here, let us consider why I have to introduce registers. I have to explain this. It's not I can go directly, but if you know what is a register, what is the use of that, then it will be easy for you to understand. Actually, inside a CPU, as everyone knows, there will be a ALU for performing operations, and we will maintain our registers, and we also have a control unit for knowing from where we have to go, whether it is storing the result back to memory, or whether it is from memory it is going. For that, necessary control signals need to be generated, that is a use of control unit. But what about this register is that if you are given in an instruction a plus b, a plus b, it won't be accessing for this ALU, it goes for ALU for addition. For addition, coming to a and b operands will be stored inside these registers. Okay, the size of these registers will be starting from 8 bits. We don't consider 4 bits. Starting from 8 bits, we also, if you go for a latest processors, you will even have a 128 64 bits like that. So why I'm saying processor means based on the processor. If processor is 64 bit, then the registers will be 64 bit. If processor is 8 bit, 8085 is a 8 bit processor. So you will have 8 bit registers. So now I don't want to go for an advanced level like 64 bits, 128 bits like that. I'm going for a basic level called 8 bits. So that is the reason that there is that is the reason that here the number 53 I'm representing in 8 bits. Okay, so in this entire 8 bits also, as we need to start from in this 0 1, so on until, as we are starting from 0, it will be until 7 or 8.
7.
Yes, 7. Okay, it is 7. Okay, now in this representation, this is your 8 bit register. So in this 8 bit register, the number 53, you are only using this entire from 1 to 7, where this is used for representing whether that number is negative number, positive number, or negative number. Okay, so see here. So here in this 8 bit register, in this 8 bit register, most significant bit, one bit I am storing for storing its sign. So 0, so here you try to see 0, 0 in this case is positive, 1 in this case is negative. Means in that MSB, if it is stored 0, that indicates it is positive number. Okay. So in this case, if it is stored as 1, then it is indicating that it is a negative number. Okay. So see here, let me represent the same. Instead of going for a 8 bit, let me go for a 4 bit register. The size of the register I'm using is one which is very low. 4 bit means a nibble size. I'm going for a nibble size, so I'm going for 4 bit. So in this 4 bit I want to represent 3 minus 3. So if I want to represent minus 3, you have the register size as 4 bits, 1 2. So from 0 to 0 1 2 3. Okay, 4 bit size. So minus 3, 3 as everyone knows, it is represented as double 1. So write down double 1. Okay, next left out bit as 0. In this MSB is used for storing the sign bit. So 0 is positive and 1 is negative. Okay, so should I, it is minus 3. So should I place here 1 or should I place here 0?
One.
It has to be placed 1.
One.
Okay, so similarly, if it is plus 3, so what must be represented there? 0. And this you have to represent definitely a different part this part need to be represented as magnitude. Okay, this is your magnitude part and this is your sign part. This is your sign part. If in sign part, if it is 1, that indicates it is negative number, and in sign part, if it is 0, that indicates it is positive number. So in this place I am placing 0 means it is positive number, followed by your 3 representation. So 0 1 1. Okay, so you in negative number representation, you are in which, whether you are in sign, whether you are in ones, whether you are on twos, based on that we will decide what number is this actually. Okay, is it clear what is signed magnitude representation? If you are having total n bits, try to concentrate. If you are having total n bits, total n bits are not used for storing your magnitude. 1 bit for sign, if it is going 1 bit for sign, then let us consider if n equals to 8 bits. Then how many bits we are storing for magnitude and how many bits we are using for sign? 1
7
bit.
bits magnitude.
Yes, 7 bits for magnitude, 1 bit is for sign. Okay, so in this way, so here we are using 8 bits. Further 8 bits, you can even divide it into 7 bits for representing magnitude and 1 bit is used for representing a sign bit. Okay, so see here, try to concentrate. Range is very important in each every negative representation sign, 1's complement, 2's complement. So here in sign and magnitude representation, as we just now discussed, 0 is for positive and 1 is for negative, and remaining bits are is used for representing magnitude. So see here, four bits here. I'm considering n equals to 4. So if you see the combinations, if you write in your notes, the combinations will be from 000 to 111. Okay, but if you see as per the concept of signed magnitude representation, it plus, in the most significant bit, if there is a plus, you blindly you can write as it is plus. Okay, so in this case, in the most significant bit, as we are having 1, so simply I have represented as minus. So next is remaining 3, you try to concentrate. Remaining 3, 0 0 0 is 0, 0 0 1 is 1, 0 1 0 is 2, like that it is represented. So see here, this 4 zeros indicates it is positive 0 and 1 0 0 0, it indicates it is a negative 0. So two combinations for 0 is not a good idea. So that is a problem in this signed magnitude representation. Okay, so coming to this, coming to signed magnitude example, previous case we have considered register size as 4 bit. So if register size as 4 bit, what will be the range is very important. So here if we have a 4 bit to represent a signed binary number, 1 bit we are using for a sign and remaining 3 bits we are using for a magnitude, then what will be the range for that? Okay, so if you see the range, you can identify, but we need to write in a formula representation, right? The range will be from -7 to +7. By this you can able to see and you can answer the range will be from -7 to +7. But in this case, how to represent that is n minus 1. Why you have to represent n minus 1? Because one bit is you are going for a sign bit, so the range for that is 2 power n minus 1. And can anyone tell me what is this minus 1 is actually? Why there is a need of
Uh,
writing
we
minus 1? Why?
need n minus 1, no, ma'am.
Yes, yes. Why? Because as we are starting from 0, definitely there should be minus 1. If you are not writing minus 1, it will become 8. Okay. So 8, as we are starting from 0, you have to write minus 1. So in this way, so number of bits used is 4. So number of bits used 4, minus 1 will be 3. So 2 power 3, 8. 8 minus 1, you will get minus 7, 2. 2 power 3, n I am considering 4, but minus 1 it will be 3. And 2 power 3, 8. 8 minus 1 will be 7. So this is your range. But when you are going for a range example, you have to represent this. Okay. When you are going for a range example, you have to represent this 4 bits. Even you can go for 3 bits also if it is well and good. So let me show for 3 bits. So 4 bits means if you go for a range, it will become. So see here, 3 bits. So in this 3 bits, one bit is used for sign. So this is your sign magnitude representation. What will be the range? Substitute the formula and tell me what will be the range. It will be minus 3 to, it will be minus 3 to what, ma'am?
Plus 3.
It will be minus 3 to plus 3. Okay. So whenever you are writing a formula for range, a range for signed magnitude representation, that is minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1, you have to show with some example why you are getting plus 3 to minus 3. Why? Because so here as most significant bit you are using 0 by default. If it is MSB part 0, then it is positive number. If MSB part is 1, then it is negative number. And try to write the corresponding binary number so that you will get. Okay. So let me go for the previous one. So what is can anyone tell me where are we? In this. So note down, this range is very important. You will get in your midst for short questions. Range. So whenever you are writing a range, you need to consider 2 bits or 3 bits or 4 bits, and you need to write this formula in your notes. Okay. Now coming for, try to concentrate more. We are not implementing in any system signed magnitude representation for subtraction operations. Why? See here, the first problem is two representations for a 0. So for plus 0, we are having 0 0 0 0, and for minus 0 we are having 1 0 0 0. And let us consider in ones and twos complements what we have done, ma. Complements we have converted to addition with the help of complementing the negative number, right? Here, if we see the signed magnitude representation, we will check whether it is working or not. See here, 4 means 0 1 0 0, 3 means 0 0 1 0. If you add 4 plus 3, you are getting 7. Try to see my mouse positions, ma'am. You are getting 7. Now let us consider 4 minus 3. Okay, na? So 4 minus 3 means you have to get 1. 1 is your answer. So what we are doing, 4 means as what we are writing, 0 1, and 3 minus 3 you are representing as what? Minus 3 just now. Can anyone tell me minus 3 in signed magnitude representation? Minus means in MSB
1
part.
0 1 1.
Yes, 1011. Just now we discussed the same example. 1011. What we are performing? We are not performing subtraction. See here, 4 plus, like we have done in ones and twos complement. What we have done, a minus b, we have converted to a plus minus b, right? So here, instead of doing subtraction, what we are doing is addition. But what is happening here? We are getting some other answer which is completely wrong. But let me see, if we do subtraction, will we get the same answer? Yes, we are getting the answer called 1. So if it is internally not supporting what? An addition operation. So see the same example. See one more example, minus 4 plus 3. So minus 4 in signed magnitude representation is 1 must be placed by seeing this you can able to understand it is minus 4, and 100 is 4, and plus 3. And if you do addition, you are getting some results which is not equal to 1. So if you do subtraction, you are getting the actual result. So that is a problem in signed magnitude representation. To overcome that, we went for ones complement representation. Okay, so here I will not explain how to do ones complement again, man. So you must know again, and I have taken the same example, 4-bit representation. In this case, what I have taken, the same example I have taken. But by seeing this, you cannot able to identify whether it is minus 0 or not. Now anyone note down in your notes, by seeing until 0 to 7 it is same. Okay, until 0 to 7 in this also there will be difference. So how can you know, how can you say that it is minus 7 in one's complement? Can anyone? One's complement, how to do?
We are converting zeros to one and one to zeros, no, ma'am.
Yeah, yes. Do you have to consider first a positive number? First positive number తీసుకొని దాన్ని negative, you have to do ones complement so that you will get a negative number. Yes, so let me take one number called 6. So 6 ఏంటమ్మా 0 1 1 0. This is your plus 6 representation. Okay, so if you want to represent in ones complement minus 6, you have to do ones to zeros and zeros to ones, right? So as we have 0 here, 1 1 means
0, 0, 1.
0 0 1. So this is your minus 6. So మనకు 1001 place లో minus 6 ఉందా లేదా చూద్దాం. Yes, it is minus 6, right? So in this way we are representing ones complement representation. For example, plus 0 0 0 0 0 ఉంది. If you toggle means 1 to 0 0 to 1, if you toggle you will get minus 0 representation as 1 1 1 1. Okay, so can anyone tell me the range? What is the range here?
Minus 7 to plus 7 only.
Minus 7 to plus 7. The formula used for sign magnitude and one's complement will be same. Okay, so see here, 4-bit combinations I have taken, but if you are considering in this way representation is complicated, you can represent in this way. Okay, so here first write down plus representation and minus representation in this way. And once if you see here, by default you try to concentrate ma. At the end I will ask you the questions. In ones complement also, for showing your negative number in MSB part, by default you are having 1. Is it
Yes,
am I?
ma'am.
Yes. So if in one's complement representation in MSB part, if you are having 1, by simply you can consider that it is your negative number. Okay, so you have to know whether the answer you got correct or not. And while doing binary subtraction using one's complement, again you have done one's complement so that you got the actual answer. Okay, so here the range for one's complement also, what is the range that we are using is minus 2 power n minus 1 minus 1 to plus 2 power n minus 1. So consider n equals to 4. The same, try to substitute. So n equals to 4. 4 minus 1 you will get 3. 2 power 3 8 minus 1 you will get minus 7 2. Again you will get 8 minus 1 plus 7. So this you will get the formula. So it will be same for signed magnitude and one's complement representation. Now, can anyone tell me what is a drawback in this? I already given one drawback in while doing binary subtraction using one's complement. What is a drawback in one's complement?
Takes more space.
ఏంటమ్మా drawback ఏంటి? Anyone? Subtraction, binary subtraction using one's complement.
There is a carry we need to add.
Yes. Good
one.
answer. And around the carry, we need to add the carry to the result. Okay, we need to add the carry to the result. So here, while solving an arithmetic, so arithmetic here, whereas in signed magnitude representation, we cannot go for addition, whereas here it is solving that problem. So ఇక్కడ ఏమవుందమ్మా sign లో, if you convert this to 4 plus minus 3, here it is not solving, you are getting some other result if you convert that to addition, whereas in one's complement we are getting the solution, so we are getting the correct answer. But the problem here is the carry need to be added to the result for generating your result. Okay, so that is a problem in this one's complement. And even 0 also you are having. What's another problem? You are having again two combinations for 0. For plus 0 we are having 0 0 0 0, and for minus 0 you are having triple 1. Okay, so to overcome that we are going for another representation of negative numbers. Which one is that?
Complement.
2's complement representation. So 2's complement representation. Now let me take the same example called 6. Okay, already we have done. Can anyone tell me how to do 2's complement of a given
First,
number?
we should do one's complements,
One
then
is
Just
to
add
add
one.
one, ma'am.
Yes, yes. Already we have a 1's complement here, right? So let me add 1 so that we'll get a 2's complement. So I'm adding 1 so that you'll get 0, 1, 1, 0, 1. And 1 0 1 0 minus 6 in 2's complement. Antena? Yes, 1 0 1 0 is minus 6 in 2's complement. Now, can you see the range here? Even a
Minus 8 to
difference of
plus 7.
yes, yes.
Minus 8 to plus.
Minus 8 to plus 7. ఎందుకు వచ్చింది one more? Why there is a added
Because
one more
only
negative?
1 0 is there, ma'am.
Yes, yes, yes. So let me go for zero representation so that you can understand clearly. As we are representing a register size as 4 bits, by the size of the register need to be considered. So even a single 0 can also be written, but the representation here, the size we have considered 4 bits. So I'm considering 4-bit register. So first, in order to do 2's complement, first you need to do 1's complement of that. So if you do 1's complement of that, you will get all 1's. Then in order to get 2's complement, we need to add 1 to that. So if you add
It will
1
be
to that,
same, all zeros.
yes. So let me see. 0 1
Last one we should
0
ignore it.
1. Last one we need to ignore. So this is your answer. So even in a negative number, 0 should not be checked as a negative or positive. So we got an exact answer. So 0, so minus 8. So you need see here, ma. So for 0, if you add 1, so you will get a 0. So this is used even for 2's complement representation also. You try to see MSB part. If you see MSB part, you can able to identify it is negative number. Just a minute. Yes, ma'am. So here for a negative number, for negative numbers, if you see the MSB, you can able to identify that it is negative number. Okay, but to know whether that number is 8 or 9 or 6, definitely you have to do 2's complement, then only you can able to identify. Okay, so now coming for the range. So this is your range. Substitute and tell me, ma'am, whether you are getting minus 8. So n equals to, I am taking the same example for signed ones and twos. I am considering 4-bit only. So if you are going for a 4-bit, so you have to get here minus 8. So if you want to get here minus 8, what do you have to do? If you write again minus 1, what happened, ma'am? What happens?
Minus 7.
Minus 7, but here we can even represent minus 8, so we are removing minus 1. Remaining will be same as it is. Okay, so the formula for the range for 2's complement is minus 2 power n minus 1. Definitely it will be n minus 1. So here minus 2 power n minus 1, and it will be in the range in the middle, and it to plus 2 power n minus 1 minus 1. Okay, now which one is advantage? Can anyone?
Third one only, ma'am.
Yes, 2's complement only. Why? Because in 2's complement we are overcoming the problem 0. We are representing only 1 0, and coming to addition also. Subtraction can also be converted to addition with the help of 2's complement. Whereas in ones also we can do, but the problem in ones is that there is a problem of end around carry need to be added to the result. Where here we are overcoming that problem with the help of, we are ignoring that directly, we are getting the result. Okay, so let me see the representation. Previously I have considered 4 bits. Now let me see for 3 bits. చెప్పండమ్మా 3 bits. So see here, signed magnitude, ones complement, two's complement. So here 0 in this case represents positive number, 1 in this case represents negative number, and remaining 0 0 you are converting to the number, so that you are getting 0 0 means 0, 0 1 means 1, 1 0 means 2, 1 1 means 3. Here also, but here you cannot say as in ones complement representation. One is by default for all the 3 most significant bit. If there is a 1, by default you can write as negative, but you cannot convert directly. If it is 1 1, it is 0. You have to do ones complement, then only you can able to identify whether it is 0, 1 or 2. Okay, now everyone write down 13 minus 13 minus 13 in signed magnitude, in ones complement, in two's complement, and tell me the result. Share the result in chat box. Minus 13. Use 5 bits.
5 bits.
Register storage size consider as 5 bits. ఎక్కడ పెట్టాలమ్మా? What is 13? In place of 8, in place of 4, and in place of 2 or 1?
1, ma'am.
1.
So this is your 13 representation. So definitely if you go for a sign bit, as it is minus 13, so 4 bit representation is not sufficient. So that is the reason I have considered 5 bit register. So if it is 5 bit register, so minus 13 is what? 1 1 1 0 1. One's complement. One's complement
1 0 0 1 0.
1 0 0 1 0. Two's complement.
1 0 0 1 1.
1 0 0 1 1. See, as is all 3 are negative numbers, so by default in MSB part all you are getting MSB part as 1. Okay, so for all the negative representations, and everyone must know that as we are implementing internally circuits, and whatever it is designed internally for converting this addition to subtraction, maximum will be used internally two's complement only. Okay, so that is the reason why internal circuits has designed two's complement. Why not signed? Means signed will not be supported, arithmetic addition will not be supported, whereas in ones it will be supported, but the problem is end around carry. So for that end around carry, again we need to design a new circuit for monitoring, and again if there is a carry generated, we need to add that result. So whereas in two's complement we can simply ignore that and we'll get the result. So in maximum of the internal circuits, it will be implemented in two's complement only. Okay, so let me go for here ma. For signed binary number, so see here minus 15. Okay, minus 56, like that. So in your question it will be given one number and try to represent that in signed magnitude representation, one's complement, two's complement. It will be given in 1 mark, or it may be asked as range. It will be asked for write the formula for a range. Okay, so let me start. See here, 4 bit example. 4 bit example, if it is positive number, if it is a positive number, means it is unsigned binary, then you will get complete n bits. You can utilize complete n bits. And coming for a signed numbers, for the entire 4 bits, you have to represent that in a negative as well as in positive. And see here ma, See here, if it is positive, then definitely in signed in ones, in twos also, MSB part will be 0. Okay. So whereas in negative representation, MSB part will be 1 in signed ones and twos complement. And the range for 4 bit will be -7 to +7, and range for, if it is 4 bits, if n size is 4 bit. Now everyone calculate, if n size is 16 bit, can anyone tell me what will be the range for twos complement? If n equals to 16, substitute in the formula and tell me.
-16 to +15.
Yes, -16 to +50. Why? Because if I consider every time 4 bits, again some students will be like, it will, the range is like -7 to +7. They will like, some students will be like that. So now everyone write down side heading overflow. Now everyone write down side heading overflow. Now, before going for this overflow concept, now actually what is this overflow? Can anyone? So try to consider, ma'am. Internally, just now I said that registers, the internal register size, if you are taking 4-bit register size, means what? If how many registers are present in that processor, those many registers, the capacity will be 4 bits. Okay. So in some cases, if you do addition of two numbers, and if you are getting 5 bits, means addition of 4 bits and 4 bits, if you are getting 4 bits, okay, no problem, the answer that you got, no, there is no overflow. Now let us consider, there is a 4-bit register and one more 4-bit register. For those two registers you want to perform an addition, but the result that you got as 5 bits, but the register size is only 4 bits, right? So there is an overflow. So how can you identify that there is an overflow? Is that is one case. And in the other cases, summing two positive numbers can give a negative result. So see here, if you want to add 6 plus 4, the result need to be, the result, if you are getting negative number -6, this you can understand if you really convert, ma. So -7 to -3, if you are doing two negative numbers, the result you have to get a negative number only, but you are getting positive number. So in such cases you will get an overflow. Let me show with an example so that it will be very much clear for you. See here, ma. Yeah, I am using 2's complement. Why? Because we are internally designing using 2's complement, so I'm concentrating on 2's complement only. So adding 7 plus 1. So see here, 7, 1 plus 7. Okay. So here 1 I'm representing as 0, 0, 0, 1, and 7 as representing. If you add, you are getting what? 1 triple 0. ఒకసారి దీన్ని 2's కాంప్లిమెంట్ చేయండి అమ్మా. 8 అయినా చూడండి ఒకసారి.
It will be the same only, ma'am.
Yes, ma'am. 8 only.
8 only kada. Okay. So why I'm saying why I'm saying as -8, don't confuse here. You have to perform addition. So now after performing addition, as everyone knows that if there is an in the MSB part, if there is one that indicates that it is negative number, to identify which negative number is that, definitely you have to do 2's complement again. So let me show, as no, I know that 80% of the students know, but remaining 20% definitely I have to explain. Main concentration is those 20% student, not the 80%. Anyhow, the other 80%, even if we explain or not, they will learn anyhow. So what example that I have taken is 100 వచ్చింది మనకు వచ్చిన రిజల్ట్ 1000. So by seeing this result, I can able to identify that this is the negative number. But whether it is which number, again you have to find out 2's complement of that, so that you can get the what number is that. So 1000, if you do 1's complement, what we will get? 0, 111 we will get. Again, if you do 2's complement, what we will get? We need to add 1 to that. So if you add 1 to that, what you will get? 0, 1, 0, 1, 0, 1. అంటే ఇది +8. ఓకేనా? అంటే మనకు వచ్చిన రిజల్ట్ ఏంటి? -8. ఓకేనా? సో here means what? Adding two positive numbers, we need to get what? +8, right? but we got negative. That indicates it is an overflow. So how can we detect an overflow? You try to see here, ma. Is there any lab today?
No, ma'am.
No, kada?
No,
Just don't share any messages, and extra 10 minutes will be taken. I will close this. If I am closing this, means only 2 topics will be left in first unit. So overflow detection. Try to concentrate, ma. Let me see how many are there. See, initially if I see 54, now it is 50. And what? Overflow detection. So when two negative numbers are added and the answer what we are getting is positive, and when two positive numbers are added and the answer what we are getting is negative, then we need to consider it as an overflow. Okay. So try to concentrate here, ma. So overflow can be detected by checking. ఎలా చెక్ మనం ఎలా మనకు ఎలా తెలుస్తుంది there is an overflow? We have to check what MSB part of 2. Here if it is 0, we know that it is positive. Here it is 0, we know that it is positive, but the result generated is what? Negative. నాకు నెగిటివ్ అని ఎలా తెలిసింది? MSB part లో 1 ఉంది కాబట్టి. ఓకేనా? So how many bits I am comparing? Can anyone? ఎన్ని బిట్స్ కంపేర్ చేస్తున్నానమ్మా? 2 bits, 3 bits? ఇప్పుడు ఇందులో ఉన్న ఇది పాజిటివా కాదా అని we are checking here in A, and even we are checking here in B, and even we are checking the result in answer also, right? If it is 0, then that indicates the answer that we got is positive. If it is 1, we know that the answer that we got is negative. Means we are using 3 comparators for detecting internally whether there is an overflow or not. Okay, try to concentrate. My overflow is very important question. So here, so overflow can be detected by checking MSB part of 2 operands and answer. Okay na? So mottam 3 we are checking in order to identify the first one in operand A, the first one in operand B, and the answer. So 3 comparators used. Whatever that we are designing, the solution that we are designing should be in such a way that comparators should be less. Ala cheyali ante what we have to do? Overflow can also be detected using 2-bit comparator just by checking carry in and carry out from MSB part. Okay, so what is this carry in and carry out? Let me explain. So carry in and carry out. So see here, what is this carry in? Just 5 minutes, I will end the session. So let me take 1 0 1 1 0 0. Okay, just I am doing addition. We are getting 0, 1 1 means we are getting 0 and 1. Okay, so this is your carry in. Okay, this is your carry in. So where we will check this carry in is in MSB part. ఇది MSB part position ఏ కదా మనది. Okay, so when your MSB part, from this column, if your carry generated, you will have a carry in. What about carry out from this MSB? Is there any carry you got? Means what? You are having 1 plus 1 is 0 1. Yes, you got a carry. వచ్చిందా carry MSB part నుంచి? Yes. So you must know. Yes, ma, try to concentrate. You only must know what is carry in, carry out. Remaining is very easy. Carry in and enti? Carry in is in on the MSB part. Is there any carry generated from this column? Yes, generated. Why? Because here 1 plus 1 means 0 1. So this is your carry in. What is carry out? MSB column nunchi whenever you are getting a carry out, then it is carry out. Okay, so let me show this with an example so that see here. Okay, from this, if there is a carry generated, then it is carry in. From this MSB position, if there is carry you got a carry, then it is carry out. అర్థమైందా? carry in, carry out?
Yes, ma'am.
Everyone. So here you must know internally, as we know that In this case, as we know that when two negative numbers are there, if you are getting positive, by seeing this as a human being can understand, if it is positive number, it's 0 0, it is positive number, but we are getting negative number. Two negative numbers, we are getting positive numbers, but we can understand. But internally, how system detects is with the help of this carry in and carry out. It uses one gate called XOR gate. So try to see here, it's very important. In order to detect overflow, internally system uses a gate called XOR gate. This is a gate representation, and these are the inputs. Two inputs is for this gate. So if two inputs we are giving, means how many combinations we will get? 2 part 2, 4 combinations we will get. Okay, so 0 0 0 1 1 0 1 1, so you will get 4 combinations. So if both inputs are same, the output will be 0. So 0 0, the output you got 0. 1 1, the output you got 0. For the remaining cases you will get 1. Okay, so see here. So when both are same, then there is no overflow. Then if both are different, means if carry in and carry out. So let me take this example, ma. -8 plus -1. Okay, -8 in 2's complement representation ఏం వస్తుందమ్మా? నోట్స్ లో చేసి చెప్పండి నాకు, anyone. -8 in 2's complement representation, just now we have discussed, it is 1 triple 0.
1,000.
Yes, it is 1 triple 0. And -1,
1 dot only
1 1 1 1. Okay, so we are performing what? Addition. So if you are performing addition, what we are getting, ma'am? ఒక్కసారి నాకు చెప్పండి. -8 -1 చేస్తున్నామా? -8 in 2's complement is 1 0 0 0. -1 in 2's complement?
All
Triple
ones,
one.
4 ones, ma'am.
All ones, okay, all ones. And we are performing what? We are performing addition. So if you want to perform an addition, see here, we need to concentrate this is very important. Okay, so let me check. 1 1 1. Is there any carry from this column to MSB? No. So అప్పుడు ఏమవుతుంది? క్యారీ ఇన్ ఏమవుతుంది? సైడ్ రాసుకుందాం. ఇక్కడ క్యారీ ఇన్ ఏమవుతుంది? ఇక్కడ క్యారీ ఇన్ ఏమవుతుంది? 0నా 1? 0. నౌ క్యారీ అవుట్.
0, ma'am.
Okay, 0. Good. Okay, carry out. Coming to carry out ఏమవుతుంది?
1,
1 plus 1. 1. Carry out 1 అవుతుంది. Okay, according to XOR gate, if both inputs are different, ఏమొస్తుంది అవుట్పుట్? XOR gate ఇందాకే చెప్పాను కదమ్మా. అంటే ఏమన్నట్టు?
1.
Yes, we got 1. Okay, that means what? Let me show an example. Means overflow na on or off? Overflow. Is overflow detected or not detected? అమ్మా మీకు XOR గేట్ వదిలేసేయండి అమ్మా. ఇక్కడ ఏముంది మనకి? 2 పాజిటివ్ నెంబర్స్ ఉన్నాయా, 2 నెగిటివ్ నెంబర్స్ ఉన్నాయా? 2 నెగిటివ్ నెంబర్స్ ఉన్నాయి, కానీ వచ్చిన రిజల్ట్ ఏంటి? పాజిటివ్. మనకి by seeing, human beings can understand that there is an overflow, but how system will know that there is an overflow? With the help of XOR gate. XOR gate carry in carry out 1 1 వచ్చినా 0 0 వచ్చినా 0 వచ్చింది అంటే no overflow off లో ఉన్నట్టు. ఓకేనా? 1 వచ్చింది అవుట్పుట్ అంటే that indicates that overflow is on. Okay, so మనకు ఓవర్ఫ్లో ఆన్ లో వచ్చిన 1 indicates on, 0 indicates off. Okay, but internally we have to consider like that, on and off. Okay, so if it is on, that 1, that indicates that is overflow is detected. So మనకి ఇక్కడ ఏం వచ్చిందమ్మా? So in this case, is it overflow detected or not detected?
Detected.
డిటెక్టెడ్. ఎందుకు? క్యారీ ఇన్ మనకి చేసే టైంలో 0 ఉంది, క్యారీ అవుట్ వచ్చేసి మనకు 1 ఉంది. అకార్డింగ్ టు XOR గేట్, ఇఫ్ ఇట్ ఈస్ 0 1, ద అవుట్పుట్ విల్ బి 1. 1 ఇండికేట్స్ ఇట్ ఈస్ ఓవర్ఫ్లో ఆన్. సో ఓవర్ఫ్లో ఆన్ ఉంది, అది వదిలేద్దాం మనం, XOR గేట్ వదిలేద్దాం. బై సీయింగ్ దిస్ రూల్, ఎవ్రీ వన్ నోస్ దాట్ Everyone knows that if two negative numbers are added and the answer comes positive, overflow is detected. So even if you don't know XOR gate also, you should able to identify by this example that overflow will be on. Why? Because MSB position లో 1 ఉంది అంటే it is negative number. But in this MSB position there it is 0. It is positive number. Without XOR gate also you should able to trace that it is an overflow. Now coming for the second example, see here, +7 is represented as 0111 and +1 is represented as 0001. Overflow on or off? Can anyone do in your notes and tell me? 7 1 యాడ్ చేస్తే ఏమొస్తుంది?
8.
On or off? Choose XOR gate and tell me. 7 representation, can anyone? 0?
0
1?
0
We need to concentrate where? ఇట్లా పెట్టేసుకుందాం. Carry in, carry out. Side we will write side. Carry in. It is very important, ma. Carry out. Okay na? So carry in ఇక్కడ చెక్ చేస్తాము. So
Carry in is 1, carry out is 0.
carry in is 1, carry out is 0. అంటే ఏంటి? According to this XOR gate, is it on or off?
On, ma'am.
On. Okay. So 0 1 0 1 0 1, carry in equals to 1, but if you add there is no carry out, so by default it will be 0. So it is on. Even XOR gate చేయకుండా కూడా internal గా system కూడా చేయకుండా we can even able to trace, right? So why? Because in this positive in MSB part it is showing as 0, but in this result generated in MSB part it is showing as what? A negative number. That indicates it is a overflow. That indicates it is an overflow. But internally system will not check like that. With the help of a gate it will use it will detect. What gate is that? XOR gate.